to you. I don't know, y'all. I'm having my in-laws over for Thanksgiving this weekend. Not like a traditional Thanksgiving. They're actually going to bring steaks and we're going to grill out on the grill. But I don't know. I don't want to get sick. I don't know. I feel like they would judge us if we wear masks while we're over there. We all sit outside the entire time. But I feel like maybe that's what we need to do. I don't know. I don't know what to do. I don't want to get sick. I don't want to miss work. Okay, so let's see. Where we left off yesterday. What were we talking about yesterday? Just before we left. It's right here. Oh, I wanted to mention because we saw this picture of the beach that was like all shells. And I could barely read the name. I think it's like Sanibel Island in Florida. I'd never heard of it. And then literally right after y'all left, I was standing in the hallway reading through some news. I saw a news story that Vice President Pence had to cancel his trip to Sanibel Island in Florida. And I was like, I literally just showed a picture of that in class. I was like, what a coincidence. So I figured I'd mention that to y'all. It must be a really nice place if the vice president goes to vacation there. But I hope he wears flip-flops when he goes to the beach because I wouldn't want to walk over all those shells. So we talked about wave refraction at the very end of yesterday, how the waves bend as they come up to shore, and if they hit an obstruction, they'll kind of wrap around it. And the effect is, even if it looks like an area should kind of be protected by the waves. So if you see over here, the waves are kind of coming in. This jut of land should keep the waves from coming anywhere near over here. They're going to kind of wrap around and get that wave refraction and bend as they come into contact with the land and come into that corner anyways. And so almost anywhere, your waves are going to come ashore perpendicular to the shore itself. So that's just an effect of the way that water moves and waves interact with physical objects. So now we move on to longshore transport. We have beach drift and longshore current, and we kind of talked about this the other day. This is what moves you down the beach when you go to the beach with your family. This. So here's an image of both of them. Beach drift is the way the sand moves down a beach. For each wave, it's going to come in and out, in and out. But those waves slowly kind of move it down the shore here. If you're out a little bit away from the wave action on the beach and you're playing in the water, it's also going to move you down the beach. That's called the longshore current. And actually, this is a big deal in touristy areas because, like, if you're a hotel, you want your beach to be nice. So you pay a bunch of money to bring in sand, nice soft sand, nice clean sand, to kind of replenish your beach. And then what does the water do? It's trying to take your sand down to the neighboring hotel. And they don't really like that so much. And so in some areas, you have these jetties that come out that kind of break up the beach and keep the sand from just always getting pushed one direction. But you can kind of see that happening in the illustration here and in the image. They have the longshore current labeled, and all the sand is just going to come in and out and constantly be moving down the beach. And I think we'll talk about a little bit about that towards the end of this PowerPoint. So now on to some erosional features. Obviously, waves can cut out cliffs. They can cut out platforms. We also have marine terraces. You'll see these in the image in a second. Sea arch and sea stack are kind of the same thing. A sea arch has literally an arch that connects two pieces of rock that jut out of the water. A sea stack is going to be similar, but the arch has collapsed. And so you just have like a column of rock coming out of the water. So here's your marine terrace. Here's your wave cut platform. You can see that the rocks come right up to the surface of the ocean. The waves are constantly eroding them and kind of wearing them away. This marine terrace could have been a very similar feature, maybe at a different sea level. But you also kind of have a cliff here. It's not much of a cliff in this picture, but this could be a wave cut cliff in the next couple thousand years as erosion continues to happen. So this stuff is nice. This is going to be the stuff also that you're going to slip on if you go out into the ocean. If you've ever been like in a river or right at the edge of the water, that algae gets very, very slick. So be careful. You want to slip and like land with your tailbone on a rock. Or also, this is also the kind of stuff where you see couples like posing for pictures, and then a giant wave comes and takes them out. So be careful there too. But yeah, this is your marine terrace, just like an on-land terrace. It's just right next to the ocean, and this would be a wave-cut platform, almost like a marine terrace, but actually semi in the water. Now you have your sea arch and your sea stack. These are going to be nice. Vacation excursion kind of things. If you ever go to an island or a coastal area, you might get on a little boat and come to these and kind of drive through them and view the nice geology. So this is just where waves have been crashing into the rocks for hundreds of thousands, if not millions of years, slowly wearing them away. And just by chance, it's worn away a hole in the middle of this rock that juts out. And you have this nice arch formation. It looks kind of, I don't know, kind of looks like this could be an arch just headed away from the camera. You can't really tell. But if this arch were to collapse and you just have this piece sticking up, that would be like a sea stack. And so a sea stack is just a vertical column of rock coming out of the water that's been worn away and separated from the mainland. And then the arch actually has like a hole in the bottom of it. And you have the nice arch kind of configuration. Sorry, I thought it was her coming to collect cans. So some depositional features. Those are all erosional features, how the water wears the rock away. Now we're going to get to how water deposits sediment in different formations. So we have three new things here. We have a spit, a baymouth bar, and then a tombolo. So a spit is a ridge of land extending from the land into the bay with a hooked end. And they actually have two of them here. This one's kind of zoomed in. So here is your little piece of land that extends out into the bay. And then because of the way the waves kind of wrap around due to wave refraction, you also get some deposition, and it kind of curls around and gets this like hook down here at the end. You can see another one here. The spit comes out onto the land, and then you have that hook that kind of hooks around back into this little inlet in a way. Here's your baymouth bar, this long one. And actually a baymouth bar is going to be what we have for Galveston. So if you've ever been down to Galveston, I can't do this one here. Let me go back to my computer. This is Galveston, and we at Texas have a very long baymouth bar that just kind of goes all the way down, even into Mexico. And so just to show you how long this feature is, Galveston is up here near Houston, which is not very far from the Texas-Louisiana border. So it starts over here, comes over, and you can see they have this inlet to let boats and commerce into the bay here, Trinity Bay. We have the island of Galveston, and it just keeps going all the way down. It kind of connects with the mainland here, but you can follow this all the way down, and you have this like natural bar island that kind of protects these shallow water areas of the different bays as it comes all the way down. I mean, it comes all the way down. Corpus Christi, like the Corpus Christi Island, is pretty much part of the same feature of Galveston Island, and they are very far away from each other. That comes all the way down, essentially to the Texas-Mexico border, which is right here, Port Isabel. I think it's maybe like right on the border. I don't know why they're not showing the border here, but it's right here somewhere. And so, yeah, it comes all the way down and continues down into Mexico before it kind of dies off down there. But that is a very large feature, very long feature, and that is like a baymouth bar. So if you wanted to go visit that, you could visit that in your own home state of Texas. A paltry, what, like 5 hour drive? How long it takes to get down there? Yeah, it's a long ways. If you ever take like a road trip to a different state, depending on how far you're driving, there's a non-zero chance that you'll spend most of your trip driving in Texas, and then just the very end is not very far away. So Texas is huge. It's gigantic.
I have a question.
Yes.
Do you know why like the water in Galveston is like so dirty, and then whenever you go to like different beaches in Texas, it's like not as dirty?
It's the amount of runoff, and some of it's going to have to do with industrial areas around there, but most of it's the amount of runoff and probably just the actual Gulf itself. The Gulf is not a like, I mean, it is ocean, but it's not a vast, wide ocean, and so generally you have much warmer waters in the Gulf, which is going to attribute itself to a lot more life, like plankton and different stuff like that. That's not really what you're seeing, but we do have a lot of runoff in the Gulf, and so especially right around the Galveston area. That's why your waters are going to be a little bit more brown, just a lot more sediment. Um, if you've ever seen like the Mississippi River, it's just like a deep, dark brown river because it just carries a lot of sediment. Now, some of it, depending on where you're at, is going to be some industrial kind of stuff, but in general, I'm not going to say we do a good job. We've done a better job of keeping companies from just dumping chemicals and different materials into the water. So most of what you're seeing is probably just a high sediment content. And if you look around, well, I'm not going to go back. There's a lot of water in that area, and everything from Texas is headed out to the Gulf. So it's probably mostly sediment. But maybe I'll look that up and see if somebody has a good geologic explanation for that. So we talked about the spit and the Baymouth bar, and then, well, just to go through it, a Baymouth bar is a sandbar that completely crosses a bay. So it doesn't have to be a giant bay, but a nice little small bay. If it goes all the way across, you got a Baymouth bar. A tombolo is a ridge of sand that connects an island to the mainland or another island. And I don't know that they have a picture of a tombolo. But basically, if you have like a little island out here, as the waves refract around it, they're going to kind of come around and push that sand up, and you might have like a little island or a little like land bridge in a way that you can walk out to the island on. Obviously, it can't be too far from the actual coast, but it can happen. So, barrier islands. Mainly along the Atlantic and Gulf Coast, the Baymouth Bar is going to be, if it gets big enough, it's going to be classified as a barrier island. And what that means is it kind of protects the coast from storm waves and kind of acts as a buffer between what happens out in the Gulf or in the ocean to right on the coastline. So they run parallel to the coast, originate in several different ways. They can be spits severed from the mainland. They can be created when turbulent waters heaped up sand scoured from the bottom. So as the waves come in, they kind of scoop up a lot of sand, and as they hit the shore, they're going to lose energy, and that sand's all going to stay kind of where it lands. Or it can be a former sand dune ridge that originated along the shore during the last glacial period. So in glacial periods, your sea level is going to be lower. As that sandbar builds up and the glacial period ends, the sea level rises, but the sand is still kind of piled up there. And so it could be like a long island just made out of sand. That gets left over. So here's another picture of a barrier island. They're going off the coast of North Carolina here. So this is North Carolina. That is, what's above North Carolina?
Virginia.
Is it Virginia? All right. I cannot read that. I guess it is Virginia, yes. And so you see this long barrier island that comes all the way around, covering quite a bit of the coast of North Carolina. You can also see that this barrier island is a decent amount away from the coastline, more than like Galveston or Corpus Christi. So it's also not very thick. It's just kind of like a big pile of sand out here in the ocean. Know that these features, including Galveston, Corpus Christi, and these barrier islands, are are so big, they are natural. Sometimes you might think, oh, this is convenient. I wonder how much it took them to like pile this sand up. No, they might bring sand in to make the beaches nicer sometimes, but it's not going to be enough to actually make an entire island. Not that we can't do that. There are, I think, famously the Emirates, the United Arab Emirates have built like a group of man-made islands to kind of increase their tourability. I don't know, to bring in more tourists. And I believe they're shaped like in the shape of a palm tree. But we can build islands, but things like this, that would be a huge amount of money and effort to kind of get something that truthfully is naturally occurring. So they're showing you some more of the shoreline features. You have a sea arch. You have your tombolo here. So you can see the island is out here in the water. And then because of the way the waves refract, you've kind of had sand piled up in this ridge in between the island and the mainland. And so you could walk out here to this island out in the water. They have a sea arch, and you can see that the waves are just hitting this cliff directly and have kind of worn a hole in the bottom of it. And then you have your spit here. And so the longshore current is kind of dragging all this sand along here. And you have this bay area. And as the waves kind of refract along the edge of the coast, they curl back in and kind of push that sand into this curled shape here. And you can see it a little bit here. This would be the bay. And then as the sand kind of gets dragged along, you get that nice little curve in a way. So interesting stuff. Shoreline erosion influenced by local factors. So what's going to influence how much erosion you have? Proximity to your sediment-laden features. If you get a lot of sediment brought in, that's going to help offset your erosion. If you're bringing in more and more sediment, it should just be piling up and not really wearing away as much. Degree of tectonic activity is going to help affect how much erosion you have. Topography and composition of the land. The harder the rock, the longer it's going to take to wear it away. If you have like just a lot of loose sand and silt and sediment, that's going to be easy to wear away. And we kind of saw that. I'm not going to go back to it. But with the picture of the Hurricane Sandy devastation in New Jersey, all those houses were just pretty much built on sand. And so one violent hurricane comes in, and literally their entire foundations are gone and they're all just moved around. If you build on rock, it's going to be a lot more steady and a lot harder for that kind of damage to happen. Prevailing wind, which way the wind is blowing, and what your weather patterns kind of are, and then the configuration of the coastline. But erosion is actually a big deal because most of our coast, not just in the United States, but pretty much anywhere in the world, the coastlines are big economic centers. They're where a lot of people live and work and kind of vacation. And so anytime your land is moving around at the coast, that can hurt your economy. That can hurt the people that live there. And so we actually do a lot of work to try to keep that land where it is. And so that's the stabilizing the shoreline part. We have a couple different types of stabilization. So we have hard stabilization, which is building like permanent structures. And so we have groins and we have breakwaters. Groins are going to be barriers built at a right angle to the beach, designed to trap sand. And I'm pretty sure they got a picture of this coming up. And then breakwaters are barriers built offshore and parallel to the shore to protect boats from breaking waves. You can see these at local lakes also. If you ever go to the marinas at lakes, everybody parks their boats. The boats are almost always in the water. And if you have a big storm, or if you have some, for lack of a better term, some jerk drive by in their boat super fast, making a big boat wake, it's going to rock everybody's boats and bump them up against the dock. And so they basically pile up rocks in this long kind of rock wall that surrounds the marina. And once you go through that, they have like a speed limit. You're not allowed to drive your boat very fast. You got to slow down quite a bit. And that just protects all the boats in the marina and the marina itself. So They build bigger ones out in the ocean, but we even see small versions of that on local lakes that you could go and see. So here's a example of your groins here, and these can also be like piled up rocks. It doesn't have to be like just a wall like these are, but you can see the longshore current in this case goes this way because you can see there's more sand piled up against this side than there is the backside, and so the sand naturally just wants to go all the way down the beach this way. And obviously, each of these homeowners, let's just assume they have nice houses right there on the beach. Let's assume they got a little bit of money. Whatever their community happens to be, whether they brought it in naturally or whether it exists naturally there, they brought sand in to kind of replenish the beach. They don't want it blowing like all the way down or being pushed all the way down the beach to the point where they don't have any sand anymore. And so they're going to put up these groins here, and that's going to kind of keep this sand all in one place. And maybe a couple times a decade, maybe once a year, they will bring in machinery like a little backhoe, a little bulldozer, and kind of drag this sand back level and kind of level everything out. And then after a while, it kind of pushes itself up against the groin again, and you kind of re-level it back out. So sometimes if you go to the beach, I don't go to the beach too often. I don't know that I've ever seen it. But you'll see like construction equipment moving sand around and kind of replacing it and keeping it in the places they want it to be. Here's a breakwater. This is not a large one, but essentially you have this dock out here. The dock extends out into the water, and you have boats anchored here. And so what you don't want is if you have a big storm or you have a large boat kind of come by here, you don't want those waves kind of knocking your boats around and making them bump against the dock or bump up against each other. And so they literally just built this breakwater. It's probably just going to be a pile of rocks that comes all the way up above the surface of the water. And when the waves come in from a storm or from some passing boat, they hit the breakwater, and they're not going to transfer out into the rest of the boats or to the dock. So that's kind of a small one, but I'd imagine it costs a lot of money to put rocks out there in the ocean like that. So a seawall is obviously going to be a wall that you build to kind of protect your coastline. It's going to be man-made. This one does look like it's just a bunch of piled up rocks. You can actually have a physical wall made of bricks or cement or concrete. The higher you build it, the more wave action it's going to be able to take. And the idea is you kind of permanently stop erosion as long as the wall is there. Often it's not going to be effective because the ocean is relentless. The waves never stop coming. And yeah, you can put something here that's less prone to erosion, but eventually the water is going to take it, and it's going to continue to do its business. There's not really a material. I mean, you could put metal there, and it might rust a lot slower than a rock would be weathered away, but that would be extremely expensive too. So, Japan has had some success with seawalls, but they're more for like tsunami protective purposes as opposed to like keeping erosion from happening. But yeah, a seawall armors the coast against breaking waves. Often it works for a small time. It's not like it's a complete waste of time or nobody would do it. But long term, it's not going to do what you want it to do. So alternatives to hard stabilization are going to be some other things. So we have beach nourishment by adding sand to the beach system, relocating buildings away from the beach, kind of planning how your runoff is going to happen, what that's going to do to affect the beach, and having a little bit of community planning to kind of keep that from happening. So here they have a dredge ship, and we do this in local ponds too. They're basically pulling up sand from out of the ocean, just off the shore, because the wind and erosion is always just going to be pushing it down into the ocean. They're pulling that back up and bringing it back on shore and piling it up and spreading it out. And so this is a constant process that they probably do. Around here, y'all have probably noticed Palmer has a whole bunch of ponds. After 10, 20, who knows how many years, those ponds fill up with sediments. The farmers will come in, scoop all those sediments out, essentially dredge the pond, and spread that dirt around on their farm fields to kind of reclaim some of that lost soil and growing material that they have. So this is a natural process. Depending on how much erosion you have, you will see it happen more often in some places than others, but it's not uncommon at all. So, how are permanent or hard stabilization efforts along shorelines? Consider the ever-changing nature of the shoreline. Know that it's always going to be moving. It's always going to be changing. Your desire as a human being to keep it the same forever is probably not going to work out for you. Consider the materials that are used for hard stabilization. The harder it is, the harder it's going to be for the waves to wear it down, but also it's going to be more costly. Consider the unintended natural side effects of hard stabilization, and consider the maintenance required for hard stabilization. Sometimes you're like, I just want to keep the beach here. But if you keep the beach here, there might not be beach left down the road where some natural beach is needed. We have the same problems with damming up rivers. We're like, the river flows. I need the water. I just put a dam here, and now I have the water all the time. And then someone downstream's like, I don't have any water left. What's up with that? So sometimes you got to think about what's going to happen if you start to keep the natural process of beach evolution from happening. So erosion is a problem along the U.S. coast, depending on where you're at. Shoreline erosion problems are different along the opposite coast, Atlantic versus Gulf. The development, or not versus, but Atlantic and Gulf coast, the development occurs mainly on barrier islands. So we're getting deposition there. They're not really, depending on what kind of storms you get, you're not really getting a whole lot of erosion. So it faces the open ocean, receives the full force of storms, and the storms are what's going to take quite a bit of your erosion away. Development taking place more rapidly than understanding barrier island dynamic systems. So instead of being like, hey, we don't really know what's happening on these barrier islands, a lot of these places, and to be fair, it's like if you've ever been to Galveston or Corpus Christi, not a lot going on other than vacationers. There's the people that live there and they love the beach life, and there's people that vacation there and they love the beach life, but not a lot of industry or other things. So they need those things. But they're basically like more hotels. The more hotels we have, the more visitors we can accommodate, and that's going to be a good thing. This is, I don't know, but you can tell, oh, here we go. 1999, does it tell me this date? Oh, they moved it. All right. I was like, that's a lot of land to wear away. These pictures don't look like they were taken that far. No, they actually had to move the lighthouse because you can see the lighthouse doesn't have too much time left here. The erosion is going to continue to happen. They even have a groin here to try to keep the sand there. It's obviously not going to work as well as you want it to. And within probably another decade or so, your foundation is going to start to get cut away from this lighthouse here. And so they're like, we got to save the lighthouse. Let's move it. And so they moved it 2,900 feet inland. Looks like they put it on a big mobile platform and relocated it to give them some more time. So that's pretty interesting. At some point in time, just got to realize that the sea is going to take it. Which reminds me of a funny story. My father-in-law apparently had this. What's it called? It's like the best four-wheeling truck ever. It's a Suzuki. Everybody always likes their Jeeps and their big trucks, but it's like a Suzuki Samurai. That's what it is. Suzuki Samurai, like little bitty four-wheeler. Looks totally stupid, and all the like four-wheel people would make fun of it. But apparently, for those in the know, the Suzuki Samurai was like a great four-wheeling truck and super cheap. And apparently, my father-in-law had one, got behind on the payments, and they were going to repossess it. And they went down to Galveston like on a vacation or somewhere on the Texas coast for a vacation. Was messing around with it on the beach, and it got stuck. And he's literally like, bah, like they're going to repossess it anyways. Just let the sea take it. And that's like one of the funniest things I've ever heard. They just left it stuck in the beach. I don't know what happened to it, but I aspire to just have that nonchalant attitude one day. Yeah, my truck's stuck on the beach. I don't care. Let the sea have it. So on the Pacific coast versus the Atlantic and the Gulf Coast, like they said, the Pacific coast is characterized by relatively narrow beaches, backed by steep cliffs and mountain ranges. The major problem is narrowing of the beaches. Sediment for beaches is interrupted by dams and reservoirs, and rapid erosion occurs along the beaches. And so in California, on the Pacific coast, they obviously have water issues. They don't get rain a lot of the year, which is why they have wildfires. When they do get rain, they have massive mudslides. They've dammed up a lot of their rivers to kind of create more lakes and more reservoirs for all the mass amount of people that live there. The East Coast, while they still have massive amounts of people, they do get more consistent rain. And so the damming of the rivers is trapping all those sediments in those reservoirs, in those lakes, and kind of keeping them from getting to the ocean. And you're kind of like right up against steep, rocky kind of cliffs. And so the beach is already thin. And as it's not getting any more sediments, it just continues to get thinner and thinner and thinner. And so depending on what coast you're on, you kind of have different problems in the United States with beach conservation. So shoreline classification is based on changes with respect to sea level. You have, what are they talking about? Emergent coast, uplift the land or drop in sea level. Yes. So emergent coast is when you're going to have new coastline kind of created. Uplift the land or drop in sea level can kind of create more land along your coast where it wasn't there before. Submergent coast is going to be stuff sinking. Land adjacent to the sea either subsides and sinks or your sea level rises. This is probably what we're concerned about the most, with the possibility of sea levels rising with global climate change. Features of a submergent coast are going to be highly irregular shoreline, lots of estuaries. So as your sea level comes up, you're going to have areas that are relatively flat. And once the water kind of comes over them, you're going to have these very shallow, large water features that are kind of a mix between saltwater and freshwater. So like the Chesapeake Bay, the Delaware Bay, these are obviously connected to the ocean, but they're also fed by lots of rivers and streams. And so you're going to have a salinity gradient here where right at the mouth and close to the end of the bay, you're going to have more salt water. As you get closer and closer to the headwaters here where your streams kind of come in, it's going to be more freshwater there. And so you can have a mix of different wildlife and a mix of different features that you have. So that is what an estuary is a mixture between saltwater and freshwater. Explain why an observer can experience two. So now we're getting into tides. I didn't see the top there. Explain why an observer can experience two unequal high tides during one day. Tides are very weird, and one thing you should remember is tides can be pulled by both the sun and the moon. The moon has the most exertion, but the sun also takes part in the tides. So changes in elevation of ocean surface is what a tide is. The water rises, the water falls. It's caused by the gravitational forces exerted upon the earth by the moon and to a lesser extent by the sun. And so depending on where the moon is and where the sun is, it's going to kind of pull your water literally to one side of the earth versus the other. Now, it's not pulling like this water molecule right here way far away. It's just kind of changing the levels, almost like if you had like a pail of water and you were just tilting it a little bit. It's not really traveling from one side to the other. It's just kind of changing its inclination and position. So this is obviously a pretty large difference in tide here. So in low tide, you're talking, I mean, it's got to be 20, 30 feet difference. Usually you only see really big differences here in tide like that for for like cutoff bay areas. This probably isn't just right on the coast. And in fact, you see the water here, you can see land all around on the other side. So this is probably an enclosed bay, which kind of helps exacerbate that. And I guess they're pointing out exactly where this is. This is kind of a mostly enclosed bay here in Nova Scotia. And I think I've heard of this place having like one of the most extreme tides in this part of the world. So that's a pretty crazy tide. Like this boat is like on the ground, way below the dock. Where, to be fair, what do you have like a ladder to get there? I wouldn't jump off the dock into the boat. That'd be crazy. But anyways, that's a pretty high tide. So we have two different terms for tides. We have the spring tide and the neap tide. Spring tides are going to happen during new and full moons, and your gravitational forces get added together from the sun, especially at high and low tides. You get a very large tidal range. So high tide and low tide are going to be very far away from each other. So basically what that means is your moon is kind of in a alignment with the sun. So here the sun is way over here. In a new moon, they're both kind of pulling together. In a full moon, the moon is on the other side of the sun, but it still creates a larger tidal range here. Versus neap tides, which neap tides, your moons are parallel to the sun's pull. And so they're not kind of added together. They're more offsetting, and your tidal range is the least. One thing that we don't really like, we've never really dealt with this because we don't live near the ocean. Has anybody ever lived near the ocean? Okay, just want to know. I don't know if everybody's always been in Palmer. When you live near the ocean, they have tides worked out for like years, if not decades in advance, because it's all about the moons and the sun. We know how fast the moon goes around the earth. We know how fast we go around the sun and the daily spin. And so it's all just mathematics, and they all kind of work it out. And so if you live like in a fishing community or a community that deals a lot with boats and has to know about the tides, they have tidal schedules out for very, very far in advance, because you never want to get caught without really knowing what the tide's going to be. So tidal patterns, many factors influence how big your tides are. The shape of the coastline, the configuration of your actual depth, water depth, ocean basin. It has a diurnal pattern and a semi-diurnal pattern, and then a mixed pattern. And so they're going to show that on the next page after we kind of talk about it. So diurnal means you have a single high and low tide each tidal day. Just pretty simple, high tide, low tide in a 24-hour period. It occurs along the northern shore of the Gulf of Mexico. It's pretty easy to kind of predict and live with. A semi-diurnal means you have two high and two low tides each tidal day. There's little difference in the high and low water heights because it's kind of going up and down so much. And then you can have a mixed tidal pattern depending on where you live. Two high and two low waters each day, large inequality in high water heights, low water heights, or both, and prevalent along the Pacific coast of the United States. They're getting a little bit more effect from the spring tides and the neap tides. So this kind of shows you what kind of tides you have. You have your diurnal, which is the simple ones here in the Gulf Coast. You have your mixed in the blue, all along the Pacific coast and most of the coast of northern South America, and a little bit up here in the northern parts of Canada. And then semi-diurnal is going to be like the east coast of South America and the east coast of North America. And it kind of gives you an idea of what you're looking at. So mixed, it's going to have highs and lows, and they're all kind of all over the place. Diurnal is going to be pretty simple. High tide, low tide, done. So that's 24 hours. Just one high tide, one low tide. The next day, one high tide, one low tide. Semi-diurnal is going to be just doubled up, but they're still pretty regular. The high tides are all pretty regular. The low tides are all pretty regular. The mix probably requires a lot more thinking about your boat and what the water levels are and where the bottom of the bay is, so you don't run yourself aground. So tidal currents, as that water flows in and out, it's going to create like a current that will pull sediment and pull different things in. So your horizontal flow accompanying the rise and fall of tides, a flood current advances into the coastal zone, and then your ebb current moves out from the coastal zone. And they sometimes create tidal deltas as they come in and out. And here's what they're talking about. So this is your barrier island like Galveston. And actually, let me go back to that because we saw something very similar to that over here in Galveston. Let me zoom in so we can see it again. They had that break where all the ships kind of come into the Houston area. And you can see, this is Apple Maps, so it's not as great. You can see that little like jut of sediment that kind of comes out from here. So you're getting a lot of sedimentation in the bay. And then as the tides go in, they're kind of pushing stuff in. And as they come out, they have more sediment in them. And so they're kind of dragging this sediment out here through this kind of break in your barrier island. And so it depends on what your tides are and where your sediment's coming from, but you can clearly see the sediments that have kind of been dragged out of the bay there. So that's what they're showing here, just kind of in reverse. You have your barrier island. As the tides come in this case, they're pushing sand off of the barrier island and pushing it into the lagoon, and it's kind of building up a delta there. So there's lots of interesting things that can happen with the tides and how they move. Yes, last slide. Explain why an observer can experience two unequal tides or two unequal high tides during one day. It's got to be mixed tides there. So depending on the moon's position, tidal bulges inclined relative to the equator. In this situation, Earth's rotation causes an observer to experience two unequal high tides a day. They did not really explain that very well. Basically, when you get your high tides, the moon's not going to be in the same position in the sky as it was earlier in that high tide. So it's not going to pull on the water the same. It's going to pull at it at a different angle and cause it to be slightly more or less high of a tide. So that's it. We're done with the ocean movement. And all we have left in the semester is just weather and air and atmosphere. And things that traditionally I don't associate with geology. So just going to throw that out there. And at OU, first off, turn the lights on. At UTA, I don't know that we really ever talked about the atmosphere very much at all. To be fair, I was a geology major, so we talked more about rocks. But at OU, the atmospheric, I believe the atmospheric people and the weather people were maybe somewhat under a different branch of the geology department, but they were let me put it this way. OU has a very large, I believe, and prestigious weather school there, and there's lots of weather people who have graduated from OU and moved on to be like TV